Lesson 9.2.
Hey, Connor.
We are doing a warm-up. I gave them a challenge of finding the midpoint and distance with radicals.
Yeah, it wasn't much.
Let's see if they remember their algebra.
Nope.
I hope Justin's not in an ortho.
Okay. I'm going to start with
I'm at the courthouse.
midpoint.
Sorry.
You done?
Yeah.
Okay. Midpoint. How do you find the midpoint?
X.
1 plus x.
Yeah.
Okay.
Over 2.
All right, good. Find halfway between the x coordinates. So this plus this. And then, good. And then find halfway. So divide that by 2. Okay. Your answer should be a point. So I should see parentheses, and I should see a comma. Same with the y coordinates. Ooh, now just looking ahead here, because I'm looking like I'm going to have to add fractions together. I don't have common denominators. Okay, Willis, you did this. How did you make this one a common denominator?
You multiply it by 2.
Okay, so I'm going to do that right away. And write that as 2 root 3 over 4. It's just going to save myself some time by making my denominators common.
Mm-hmm.
Okay. So let's review over 2 things. How we add fractions and how we add radicals. To add fractions, so I'm just looking in the top right now. I'm just trying to add together the x coordinates. Add the numerators, keep the denominators the same. What's 1 squared to 6 plus 5 squared to 6 is? 6 squared to 6. What has to be true, I guess? What do we need in order to add radicals together? Why can I add these together?
Needs to be the same.
The radicand, good. The number underneath the square root has to be the same. If this was a 7, I could not add those together.
Yep.
Okay. All right, we're here. This is still all over 2. I haven't done that yet. I would go ahead and reduce that to 3. 6 over 2. That should have been the x coordinate of your midpoint. Exact form, no decimals. Okay. Let's do the same thing now with the y coordinate. So now that I have the common denominators of 4, 1 root 3 plus 2 of them is 3 root 3s. All right, here I don't have anything that cancels. So there's a couple ways you could think of this math. You could either times by reciprocal instead of dividing by 2, but you're dividing by 4 and dividing by 2, so you're really just dividing by what number?
8.
8. Good. There's your midpoint. I got that wrong. Raise your hand if you got it right.
Not me.
Nice.
Now I got it right.
Okay, midpoint. Distance next. Oh boy.
Yeah.
Okay. All right, so review over distance formula. You got to find the difference of your x coordinates, square it, add that to the difference of the y coordinates, square it. Remember, you're just kind of like doing a fancy pipe egg.
Mm-hmm.
All right, so I started with this point. I called this like, I called this x2, y2. Again, you can label if it helps you. So I got to do 5 root 6 over 2 minus root 6 over 2. We already got common denominators. We're good. All right, same thing. I'm going to keep this one with my common denominators. 2 root 3 over 4 minus root 3 over 4. Okay, folks, what I told you is always like start in the inside and simplify this first. Kind of ignore the radical. All right, what's 5 root 6's minus 1?
4.
4 root 6's. What's 4 root 6 divided by 2?
2
root
2 root 6 is how that should simplify. Good there? Do we get that far?
Kind of.
Right.
If you need to show more steps, you can. You can show, obviously, like 4 root 6 over 2. All right, what's 2 root 3's minus 1 root 3?
1 root 3s.
1 root 3 over 4. Okay, now the fun part where we get to square this. Okay, a little algebra review. When you square something like this, you gotta square the 2 and square the square root of 6. Yep, so it ends up being 4 times 6. That ends up being 24. Are we okay with that?
Yep.
Okay. When I square a fraction, I gotta square the top and square the bottom. What's my numerator squared?
3.
3. What's my denominator squared?
16.
Good job, guys. Look at you and your algebra skills. Oh, so proud. Proud.
That's algebra.
Yeah, I guess.
That's like 3rd grade math.
Okay, well, you guys struggle with it, so what does that say? I'm just kidding. Alright, then we can do 24 plus 3/16. You can use your calculator for that, but again, don't use the radical button, just get the fraction underneath. So I got 387 sixteenths.
That's what I got.
Okay, good. If you got that far, that's really good. Now from here, it's just simplifying. This is algebra skills. You can't leave fractions underneath the radical.
Oh, it's a perfect square though.
Right. Yeah, square at the top. However you want to show your work. Square at the top. The bottom ends up being a perfect square. This does simplify. Did anyone find the perfect square that goes into 387?
Oh, really?
Yes.
Yes. 9. This is divisible by 9. So this actually simplifies to 3 root 43. Holy algebra.
That's a lot of algebra.
Okay, we didn't do one with the radical yesterday. Did you hear somebody say question?
Just for one
How
problem.
close did you get, James?
A lot of work for one problem.
Oh, I thought you said question.
No,
What did you say?
I said that's
I
a lot of work
forgot.
Oh.
for one problem.
Okay. I just hear things, I guess. Alright, good. That was just a little warm-up review.
You said this was easier than last chapter.
I think so. You don't think so?
No.
That off to a great
Easy
start.
chapter.
So this chapter, I don't know, we'll see what you guys think.
Oh,
Easier than the last one?
But we'll see what you guys think by then. It's a lot of graphing.
Ah!
Oh, Nick is so excited. Did you hear that?
You're killing me.
Can we take a bathroom break, please?
After break and never come back. Can we get
Yes.
candy at the end of the semester?
Is it too late to drop out?
Alright.
A little bit.
Don't like Okay, so this chapter we're talking about something called like conic sections. That's what the chapter title is, conic sections. So there are actually like 4 different conic sections we're going to talk about. So what a conic is, and I have this nice little YouTube visual animation thing for you to see. So you get to watch a little
song?
short clip today, a little 4-minute movie. Don't ever say we don't watch movies in that. We're going to watch a 4-minute movie today.
We watch Elf.
True.
That's the
Um,
only.
But they're basically
anime
just
watch.
curves that are created from an intersection of 2 things. A right circular cone, so you can see those in red here. And if I were to take a plane and like intersect the plane at different like angles of this right circular cone, it can kind of form like these 4 different shapes. Okay? We'll go through and talk about them, but today we're just looking at one that you're most familiar with, parabolas, because we did parabolas like all in chapter 4, but we're going to look at them kind of in a different way. So first, here's a little YouTube animation. I don't love like the lady's like voice. Some of the
Oh, 5 minutes.
well, we're gonna cut it short.
No.
She does talk about some good vocab, but there's some like vocab in here that you don't need to know. So just kind of like listen. It's more for the visual part of this. I actually don't know if my volume's up, so we'll just try this. Okay, so you see my right circular cone here. It's just a good visual for intersecting a plane, and you can see the different like conic sections that are formed. Okay. Let me set the mood. I'll turn it up.
Line intersects a vertical line at a fixed point and rotates about that fixed point. The surface obtained is called a double white circular cone.
Here's your right circular cone.
A double white circular cone consists of 2 cones joined at a fixed point called the vertex. The line that rotates about the vertex is called the generator, and the line that remains fixed is called the axis. A right circular cone has a circular base and its axis is always perpendicular line from the center of the base to the vertex.
That's what makes it a right.
The perimeter of the base is called the directrix. The lateral surface of a right circular cone is called a nap.
I need
A
That you
double
don't
right
need to know.
circular cone has two naps. The nap above the vertex is called the upper nap.
I need
Whoa.
I need
The lower nap.
Same here.
That's
Okay, the good stuff's
Also, the angle between the generator and the axis is called the vertex angle.
Look.
Common
Here we go. This is the good visual part.
If a plane intersects a double right circular cone, we get two-dimensional curves of different types. These curves are called conic sections. Depending on the angle made by the plane with the vertical axis of the cone, the plane can cut the cone in three different ways. Ellipse.
We pronounce it ellipse.
When the plane intersects the double right circular cone in such a way that the angle between the plane and the axis is greater than the vertex angle, we get a closed curve called an ellipse.
Basically, it looks like an oval.
When the plane is perpendicular to the axis, the ellipse becomes a circle. Thus, a circle is a special type of ellipse. Parabola. When the angle made by the plane to the vertical axis is exactly equal to the vertex angle, we get an open curve called a parabola at the intersecting surface of the cone. Hyperbola. The plane intersects only one nap of the double right circular cone as long as the angle between the plane and the vertical axis is greater than or equal to the vertex angle. However, if the plane intersects the vertical axis at an angle smaller than the vertex angle, the plane intersects both the naps of the cone to form an open curve called a hyperbola, which has two disjoint curves.
Okay, that's about it. Just gives you a visual where these come
It was not 4 minutes.
30, 40, you round up.
No, you don't.
Also, she pronounces, it's not pronounced hyperbola, we say hyperbola.
Ryan, do you have a
It's a American
hyperbola?
accent.
Yeah, I have hyperbola.
Okay.
Is that the worst?
Alright, so you basically could visually see here how we could take a right circular cone in a plane, we could form these four different
Sure.
shapes. So this one, and she went through and showed you all like the angles and all that jazz. We're just basically gonna like graph these different shapes. So we're gonna graph circles.
How does one graph a 3D cone on a 2D picture?
Well, you're not gonna graph the cone. You're literally just gonna graph the circle.
Oh.
Yeah. This is just where these conics
So, like, how do
come
you graph
from,
the
these
circle?
shapes. Yeah, we'll get there. Don't worry. I think that's the next lesson.
Oh, really?
Yeah.
Tomorrow?
Wait, what
No.
are we doing tomorrow?
Oh, sweet.
We're gonna spend 2 days on parabolas. This oval shape we call an ellipse.
Which is the hardest to grab?
yes.
Maybe hyperbolas. I don't know.
Have we done
These are pretty
hyperbolas
easy.
before?
These two are easy. You guys know this shape,
Parabola.
parabola. But you've only done parabolas that are like you up or you down, like happy faces or sad faces.
These are sideways.
Possibly some. Okay,
Ah, cool.
and then this last shape, hyperbola, is how you pronounce that. Hyperbola. Okay, so as we work through this last chapter, we're gonna work in all these different conic sections for the next today and tomorrow, next 2 days. We're just gonna focus on parabolas because you already know how to do parabolas
Yep.
that look like this.
Mm-hmm.
Okay. So there's kind of just a lot of vocab that goes with this stuff. And this little chart here is not to be like confusing. You don't need to like memorize this per se. If you understand what the vocab words mean, you can figure out where they're located by using like some like patterns kind of. You don't really need to like memorize these equations. You do need to memorize the form of the equation, and one of them you already have memorized. So let's start with what you're familiar with, these u up, or we know if it gets reflected, u down. These are parabolas that are explicitly solved for y, or that the equation's like in terms of x. Okay, so what I mean by that is it's always y equals, you only have ever graphed parabolas that are solved for y, or maybe you've had to do that yourself. And then we have some like factor out here. If it's positive, it means it's a u up. If it's negative, it's u down. If it's a large number, do you guys remember what transformation that means?
Skinny.
Makes it skinny, vertical stretch. Good. If it's a small number, like 1/5, vertical shrink, and it makes it y. Remember all that stuff we talked about? Okay. And then this is a shift left or right when you're just doing it inside to the x. This has to be squared. That's what makes it a quadratic equation, and that's what forms the parabola shape. Do you guys remember what goes out here?
Plus K.
Plus k. Good. And that's a what? Transformation.
Up or down.
Shift up or down. Good. And that changes my vertex. Right? If I'm looking at the equation this form, remember how HK is your vertex.
Yeah.
Because that shifts it. This is just going to stretch or shrink and reflect it. Okay, so this we already know. We'll come over here and talk about what these look like in a minute here. I can tell which way this opens depending on if A is positive or negative. It doesn't matter what the number is. If A is positive or greater than 0 is how we say that in math, is it going to be a U up or a U down?
Up.
Up. Remember I say positive people are happy, happy face. If A is negative, it's going to be a U down. My vertex
Is H.
Good. HK. And remember, it's kind of like the opposite of which A is, because those horizontal transformations, if I like minus a number, that really shifts it to the right. Okay, so you just got to be careful with that. Do you guys remember what the axis of symmetry is?
Oh, the
AOS.
the line through the vertex.
Good. It's the line that goes through the vertex. So in this little parabola, let's go ahead and draw the axis of symmetry.
So it's
I'm going to do it a different color. I often abbreviate axis of symmetry as AOS. And it's the vertical line that basically like splits your parabola in half and mirrors. That's the nice thing about parabolas, they're so symmetrical. But it goes right through your vertex. Axis of symmetry. So in this case, it's always x equals whatever the x coordinate of the vertex is. Remember that? Because it goes right through your vertex. Okay, let's go ahead and label our vertex to this point right here. That'd be our vertex. Vertex, axis of symmetry. This we already know. Okay, I'm going to introduce you to two new vocab terms. There is a point inside of the vertex that we call the focus. I'm going to highlight in blue here. And it's always located inside your parabola. So if it's a U down, the focus would be somewhere in here. Okay. This line down here that's kind of in red, the lady mentioned this in the video. Did she mention the focus in the video?
No.
I don't think she did. This line we call the directrix. So I'll kind of explain what they mean as we go here. So basically, like the true definition of a parabola in terms of like a conic section, it's the collection of every single point in this plane that are the same distance from the focus than they are from the directrix. So they're basically like all of these points on this curve are equidistant from the focus than they are from this line of directrix. Okay, it's kind of hard to visualize, but that's what the true definition of a parabola is. You don't really need to know that. You just need to know where the focus and directrix are located. So the vertex, because it's equidistant from the focus and directrix, this distance right here should always be the same. Does that make sense? If it's equidistant, this distance and this distance are going to be the same. Okay? That's what like the focus and directrix are. And they are these like fixed points and lines where every point on your parabola is equidistant from those points. Okay? So what I want you to label right there, this distance is always going to be 1 over 4a, a meaning whatever this number is. Okay? 1 over 4a. So let's say the focus is 6 units above my vertex. That means this directrix, this horizontal line, would be 6 units below my vertex. Make sense?
Sure.
Yep.
Okay, so here's like the equation for the focus. But like I said, if you understand where the focus is located and this pattern, you can like work your way and reason your way through this without memorizing the formula. Another thing I want to point out is the focus is always going to be on the axis of symmetry too. Okay? So the x-coordinate of the vertex is going to be the same as the x-coordinate of the focus because it's always going to be on the axis of symmetry. So where this focus is located is whatever the vertex is plus that 1 over 4a distance. Or minus if it's a u down, but we'll kind of adjust that. All right, and then the directrix is this horizontal line. So it'd be y equals would be the equation for that. And it's going to lie the same number of units below my vertex. So it's going to be whatever the y value of my vertex is minus that distance, 1 over 4a. All right, the only last vocab word I'm going to tell you, and it's used, I guess, maybe sometimes in like some word problems. We won't get to the word problems today. We can write down the definition for this. Lattice rectum. Hold the laughs.
Just add the left.
I knew as soon as I saw Carter turn his head, I was like, it's not
Well,
good.
he looked. He's like,
Oh gosh, we're all high schoolers here. Huh? Okay. It's the line segment that goes through the focus perpendicular. Do you guys recognize that symbol from geometry?
Yep.
Perpendicular to the axis of symmetry. Okay. So let's draw the lattice rectum of this parabola. My axis of symmetry is vertical. So what direction would my perpendicular line be?
Other way.
Straight horizontal. Good. And it goes through the focus. So it'd be this line segment right here. That is my lattice rectum. Okay, so you're going to be pretty good at graphing these because we know how to graph them already when they're in terms of x or explicitly solve for y, however you want to think of it. The only thing that's new is now you're going to have to find the focus and the directrix, but it's not hard. You guys can do it. The part that's probably going to be a little bit more challenging is graphing parabolas that open up this way. So they could open up left or right. This equation looks very similar to this one, but this one is in terms of y and explicitly solve for x. So it's x equals some value a, y minus, okay, so basically all that changes, guys, is you flip-flop the x's and y's and you flip-flop the h and k squared plus h. And I can show you these on decimals, and that's actually how you're going to check your homework. You're going to graph them on decimals. You can type this right in decimals. X equals, well, obviously I have some numbers in here, but you can type in equations on decimals that are x equals. On graphing calculators, on those fancy schmancy ones, they only let you graph in terms of x for y equals. That's the nice thing about decimals, is it lets you graph something that's explicitly solved for another variable other than y. All right, so if the equation looks something like this, an easy way to figure out which way they're going to open up is you have to check which variable is being squared. If x is being squared, it's going to be u up or u down. If y is being squared, it's going to be one of these left or right's parabola. Okay? So to determine if it opens in this direction or in this direction, we again look at the sign of A. All right, what do we think if A is positive? Do we think that means it's going to open to the right or to the left?
Right.
Why?
Left.
Because.
You're right, but why?
Makes sense.
Left is like a negative sign.
Yeah, it's opening up like towards the negative numbers on the left, right?
Yeah.
Yes, that's exactly the way I think of it.
Yeah.
So if A is negative, it opens up towards the negative numbers to the left. Okay, that's how you can remember it. My vertex is still at HK, but you just have to be careful because now the value of H is located over here and not in the parentheses, but it's still going to be HK. All right, so in this sideways parabola, this right here would be my vertex. Look what happened to my axis of symmetry. My axis of symmetry is a is a line that splits my parabola in half that goes through the vertex. So it's no longer a vertical line. It's a horizontal line. So it's y equals k. Still going to go through your vertex. Yeah. Once we do a couple, like I said, you don't really have to like memorize this stuff. Oh, I forgot to fill in this. The length of that is always 1 over a, and put it in parentheses. Or sorry, not parentheses. Put it in absolute values because we're talking about length. Units. Sorry. All right. So now our new vocab here. So I mentioned the focus is always located inside the parabola. So if this one's opening up this way, and the directrix is always located outside. They're all lie on that same like axis of symmetry. Okay. The focus should always be inside. So you can see this point right here is my focus, which is the same distance away from the vertex than this line right here, which is the directrix. Notice how my directrix is now a vertical line. Okay, so my focus in this case is going to be whatever the h value of the vertex is plus 1 over 4a. So this distance is still from the vertex to the focus 1 over 4a in both directions. I know it's kind of small. Sorry. I wanted to fit it all on one slide. And it lies on that same axis of symmetry as your vertex, so it's whatever the k value is. The directrix is a vertical line, so it's not going to be y equals, it's going to be what? X equals. Good, Carter. X equals h minus 1 over 4a. Good. Okay, you guys can see it. Minus 1 over 4a. Lattice rectum. Same thing. 1 over a units long. Like I said, I don't think you have to find that very often, but so a lattice rectum is perpendicular to the axis of symmetry. So this time axis of symmetry is horizontal, so perpendicular through the focus, this line right here. Okay, once we do a couple examples, it'll kind of start to make sense, but that's just a really good way of like organizing kind of the vocab. You do need to know these. These you have to memorize. Those forms of the equations. Okay. On your homework, you have a book assignment and then a worksheet that only has 3 questions. So on your homework, I want you to do this every single time. So you're gonna like completely ignore what the directions in the book say, and you're gonna follow these steps, okay? So it says, write the equation in standard form, graph the parabola, and then you're gonna identify all those special features: vertex, directrix, direction of opening, and axis of symmetry. Before I even start doing anything, which variable is being squared, x or y?
X.
X. So that tells you it's going to be in this category. X is being squared, okay? Which means we have to solve this for y. So they want us to put it in the standard form. Do you guys remember the process to do that? Starts with the C. T S.
CTS.
It's 3 words.
I don't know.
Completing.
Square.
Yes.
Oh. I don't remember that.
Oh, we're gonna review it. Don't worry.
I personally don't think square.
Okay.
Boxes.
Completing the square is so too.
All right. So to complete the square, the first thing I'm gonna do, and you're probably tempted to do this because we're solving for y. I'm gonna move over that 6.
Oh, I see.
Okay. In order to complete the square, does anybody remember which number we need in front of the x squared? A 1. Good. So I have to factor out that 2. And remember, you only factored out of these 2. You essentially ignore that plus 6. And I'm just going to factor out a 2 here. And that give me x squared minus 6x, leave a gap. And then I have that plus 6.
Oh, we need to get.
Leave a gap because we're going to complete the square in a second. Everybody okay with math so far? All I did was I brought out a 2 just for the first one to kind of ignore this. Completing a square is you find a number that makes this a perfect square trinomial. Okay, Riley said 9. You're right. How'd you find that number?
Divided 6 by 2 and squared that number.
Remember that little formula?
No.
You take half of b
Oh, maybe I do remember.
and then you square it. So half of -6 is -3 squared. 9 is our magic number.
Plus 9.
And I like to draw it in an actual box.
In
Then
the
you have to subtract 9 from the outside.
You're close.
Oh,
We do have to
subtract
counter
18.
it, but I really added in an 18.
Subtract.
Oh my gosh, remember this? We did 15 million examples of this in class. You guys still were like, oh my goodness.
Yeah.
Oh yeah, bringing back the times. All right, I really just added in an 18, so I have to counter that
Minus 8.
by subtracting an 18. I like to put that in a box too.
Box.
Okay, we're almost to standard form.
Really?
Now that this is a perfect square trinomial, it factors, and you can think of it as the long way to factor. This would factor into 2 numbers that multiply to 9 and add to -6, x minus 3 times x minus 3, right? But do you remember how we write it?
No.
I don't think that.
Oh.
Uh-huh.
Oh.
Times 2 and
Minus
then
12.
and then minus.
And that's our form.
Okay, remember that? No, but that's okay. Now we do. Okay, yes. Here is my equation in standard form. You don't have to, but I'm going to circle it. That's what you're going to do first. You're going to write the equation in standard form. Then you're going to graph the parabola. So again, I'm labeling out these steps because this is how I want you to do it in your homework. On graph paper, of course. All right, now as I graph it, I'm gonna kind of simultaneously start identifying my features because it says I have to identify my vertex, my axis of symmetry, and which way this opens, and we can do that while we graph it. Okay, so what I usually find first, before we even started today, I made you guys used to tell me which direction is this opening, what the vertex is, what the axis of symmetry is. So this we could have all really done before I taught you the new vocab. All right, so now that we're in standard form, what's my vertex? 3, because it shifted right. 3, -12. What's my axis of symmetry?
X equals 3.
Good job. X equals 3. Okay, and we can kind of plot this as we go too. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so remember the axis of symmetry goes right through your vertex, and since this one is in terms of x, the axis of symmetry is going to be vertical. All right, is this going to be a u up or a u down?
Sideways.
It's not going to be sideways because y is not being squared. Up because a is positive. Okay, so we just did this. We want to graph it. So all I'm going to make you guys do to graph this is just pick maybe like one other point to get the correct like width of your parabola. Okay, so I plugged in 1 and I got -4. You always want to pick ones kind of like around your axis of symmetry. So 5 would have been fine too. I plugged in 1 and I got -4. All right, folks, if I have a point here at 1, -4, and it's 2 units away from my axis of symmetry, since the axis of symmetry mirrors each side of my parabola, 2 units to the right, there's your width of your parabola. Okay. That we technically already know how to do. We're in here until 11:09. Oh, we're almost done. All right, fine. We'll do this one. So what's new for us
Focus.
is the focus
And the directrix.
and the directrix. Yep. All right, so to find these, the first thing you're going to do is calculate what 1/4a is. So looking at my equation in standard form, what is a? 2. A is 2. It's the number right here. A is 2. So 1/4a is 1/8. With me? That's the distance from the vertex that both the focus and the directrix are going to be like above or below or to the left and to the right, depending on which way this opens. So since the focus is always located inside the parabola, it's going to be located 1/8 of a unit up, just like that. You know, it's hard to draw because it's a really tiny length. Yes?
That's also the slope.
The slope.
The 1/8 between the dots. Oh, never mind.
It's like, we're not grabbing lines.
Yeah.
What's slope? Okay. So the focus, what's the x coordinate of the focus since it's on the axis of symmetry always?
3.
3. Okay, folks.
Oh.
So the vertex, which is located at -12 plus an 8. And this you can write as a mixed number if you want. 11 7/8. That would be -12 plus an 8. With me? Okay, everybody go ahead. I want you to label your focus. You can just do an F. That's my focus. Let's label our vertex too. With a V. That's my vertex. AOS for axis of symmetry. Label those. All right, last one. Directrix would be located 1/8 of a unit below. And it's a horizontal line.
-12 and 1/8.
Good, so it's y equals -12 and 1/8 is a directrix. And make sure you put y equals, it's a line, it's not a point. Go ahead and label DIR, directrix. Okay, so we'll just obviously look at some more examples today. Tomorrow. Now that you've learned all the
Brooklyn Mull and Malin Hahn to the office, please. Brooklyn Mull and Malin Hahn to the office, please. 8-hour study hall, 8-hour guided study hall, and after school guided study hall will be in the library today.